Computers are everywhere, from our smartphones to our appliances to the cars we drive. And a global network of computers supports finance, medical data, and all sorts of daily activities. A central processing unit executes programs. Those programs are stored in a memory. The memory also holds data that the programs operate on. Input and output devices, I/O devices, help the computer communicate with the external world. And all these components are connected together. A simple example is a bus. Computer engineers design computer systems, and that includes hardware. It also includes certain aspects of software. So how do we design a computer system? For example, a calculator. We know what the calculator should do. How do we build a machine that actually does that? We have two tools that are complementary. Refinement helps us take a more abstract description and break it down into pieces. For example, the user interface that talks to the user, and the math module that actually performs the mathematical functions. We can then further refine the math module into different types of math that might be performed. Abstraction helps us understand complex systems that are built from simpler components. So, the overall math functions of our calculator are abstracted from the basic, the business, and the scientific mathematical operations. One of the abstractions we use in talking about computer systems is the layer model. Lower layers are less abstract, higher layers are more abstract. Here's a simple model. The operating system manages the basic functions of the hardware. Middleware provides services, and applications are what the user sees, built on top of both the middleware and the operating system. Here's an abstraction for hardware, a block diagram. This block diagram has several components that are connected together. We refine the overall hardware design into these modules and their connections. And then as we make sure that the hardware does what it's supposed to do, we abstract from the basic components up through the complete system. This is an object in the Unified Modeling Language, or UML. We have several objects, each of a different type. So object A1 is of type helper. Object C is of type controller. The lines show how these different objects communicate with each other. These are comments that help us understand the meaning of the diagram. UML also provides a sequence diagram that shows how objects interact over time. We have 3 objects here, each with its own timeline. So B operates and sends action 1 to C, which then responds. This is a UML state diagram that shows a sequence of operations. Each operation corresponds to a state. These states can be either in software or in hardware. In this case, we read, we operate, and then we write. This is a simple representation of how we use I/O devices. We can use UML state diagrams to describe software. So here we have the start of the function. Here we have the end of the function. In between, we perform some setup, and then we loop. After each operation, we test the value of X, and if it's true, we go back to the operate state. If it's false, we go to the end. Thanks for watching.